In this part, we focus on derivatives of inverse trigonometric functions. The first one is d1 over dx arcsinx, or sine inverse of x. So, what is this? Let's start from here. Let's say y, let's give a name to sine inverse first. Let's say sine inverse is y. Is the first step to find derivative of inverse functions. We first give a name. And do not forget the domain of y here is from pi over 2 minus pi over 2 to pi over 2. I mentioned about this in the previous lecture. Differentiating sine y equals x with respect to x. You apply sine to each side of this equality, then you get sine y equals sine x. Differentiating this equality with respect to x, we have, of course, we implicitly differentiate, okay? We implicitly differentiate this equality with respect to x. Then we get derivative of sine y is equal to cosine y times, do not forget that y is the function of x. Since y is the function of x, y is not a variable. When you take derivative of y, you have y prime. Again, derivative of sine y is cosine y times derivative of inside, derivative of y. Y is a function of x. This is why derivative of y is y prime, not 1. Be careful. Derivative of right hand side, which is derivative of x, is equal to 1. Okay? What do we look for? We are looking for derivative of y, which is y prime, right? So, y prime becomes, when you make y prime alone, you have 1 over cosine y. We actually find y prime, but the answer is with respect to y, not x. As you see, the answer must be with respect to x, not y. This is why we should use this equality. Cosine square y plus sine square y is equal to 1. We know this, right? This is why cosine square y is equal to 1 minus sine square y. And finally, cosine y is equal to square root 1 minus sine square y. Okay? Do we know what is sine? Yes, we know. Sine y is equal to x. When you use this equality, when you use this information, you immediately get the requested result. Y prime, which is arcsine derivative of arcsine x, is equal to 1 over, instead of cosine y, we have square root of 1 minus sine square x. No, very sorry, 1 minus x square. Okay, since sine y is equal to x, you have square root of 1 minus x square. It is the result for derivative of inverse sine function. What about derivative of inverse cosine function? I also want to give the proof. And what about the domain of this derivative? It's also important to write the domain of this derivative. X is in between minus 1 and 1. If x is bigger than 1, then the function is undefined because of square root. if x is smaller than minus 1 or equal to minus 1, then y prime becomes undefined. Okay, so it is derivative of arcsine function. Let's continue. The next one is derivative of arc cosine, d1 over dx arc cosine or cosine inverse x. What is this? We actually use the same idea. Let's first give a name to the inverse trigonometric function. Let's say y is equal to cosine inverse x. Apply cosine to the each side of the equality. Then you get cosine y is equal to x. Differentiating implicitly with respect to x, derivative of left hand side is equal to minus sine y times derivative of inside y prime is equal to derivative of right hand side is equal to 1. Okay, then in this case y prime becomes 1 over minus 1 over sine y, right? Minus 1 over sine y. Then the same answer, we have the same problem here. The final answer must be with respect to x, but here we have y, right? So I will use this identity, and the identity cosine square plus sine square is equal to 1. I will make sine y alone and have this result, minus 1 divided by square root of 1 minus x square, using the same idea which we did for derivative of inverse sine. It is the result. I also want to give the third one, derivative of arctangent x. What is this? We exactly use the same idea. We first give a name to the inverse tangent. Okay, then apply tangent to each side of the equality. Then you have tangent y is equal to x. Again, differentiating tangent y equals x implicitly with respect to x, we get derivative of left hand side, derivative of tangent y is equal to secant square, right? Secant square y times, again, derivative of inside is y prime, derivative of right hand side is equal to 1. So y prime becomes 1 over secant square y. Again, the final answer is with respect to x, but it must be with respect to, the final answer is with respect to y, but it must be with respect to x, as you see. This is why we have to do something to convert the problem. We actually have two ways. The first way is that you may say that this expression is equal to, instead of secant square y, you may use secant square u is equal to 1 plus tangent square u. Okay? You may use this information. So this equality, instead of secant square y, you can write 1 plus tangent square y, 1 plus tangent square y, and instead of tangent y you have x, so the final answer is 1 over 1 plus x square. Okay, it is the first way. What about the second way? We also have a second way. instead of the same expression is equal to 1 over secant square. Instead of y, what do we have? We have arctangent, right? Arctangent x. Okay, so instead of y we have arctangent x, and using this identity again, you have 1 over, instead of secant square you have 1 plus tangent square tangent x, tangent inverse x. Okay, so we can write this square here actually, right? It is right? So tangent inverse tangent of x is equal to 1 over 1 plus tangent inverse tangent x becomes x. Since you have square, you have x square. It is the second way of the proof. So what about other trigonometric? What about derivatives of other trigonometric functions? I want to summarize derivatives of all trigonometric functions. The first one, derivative of sine inverse sine u. Let's say u is a function of x. Okay, instead of x, let's say we have a function. So derivative of this is equal to 1 over square root 1 minus u square times derivative of u with respect to x. Okay, here absolute value of x is smaller than 1. The second one, derivative of arc cosine x, arc cosine u. U is a function of x. It is the formula. Again, absolute value of u must be smaller than 1. The third one, derivative of arctangent u, inverse tangent u, is equal to 1 over 1 plus u square times derivative of u with respect to x. Okay, this is the third one. What about the fourth one? Derivative of arc secant is equal to, it is the formula, u square minus 1 times derivative of u with respect to x, and u here, absolute value of u is greater than 1. The fifth one, derivative of arccotangent u. U is again a function of x. The result is minus 1 over 1 plus u square times derivative of u with respect to x. And the sixth one, derivative of arccosecant u with respect to x is equal to minus 1 over absolute value of u times u square minus 1, of course, times derivative of u with respect to x. Here absolute value of u must be greater than 1. Okay, so I gave all definitions of inverse derivatives of inverse trigonometric functions. Now let's solve some simple problems, simple examples. Example 1. What's the derivative of arc cosine 2x plus 1 according to this information? So what's the formula of derivative of arc cosine? Let's remember. The second one is the formula of arc cosine, derivative of arc cosine, minus 1 over square root of 1 minus u squared times du over dx. Let's first say derivative of inside is 2 times derivative of inverse cosine is minus 1 over square root of 1 minus square of inside. 2x plus 1 square. Okay, this is the first example. So what about this one? D over dx ln sine inverse of x. This is equal to, we should know the derivative of ln function. Derivative of ln is equal to derivative of inside over inside, right? So derivative of arcsine, let me write the formula of derivative of ln, derivative of inside over inside. This is equal to derivative of arcsine is equal to, you should know the formula, 1 over 1 minus x square square root over arcsine or sine inverse. It's all up to you. Which one do you prefer? Arcscinx. Okay? So it's all. Let's solve some more complicated examples. Example. Find y prime for x cube plus x times arctangent y is equal to exponential y. Okay. As you see here, y is a function of x. So y is a function, not variable. Be careful here. Since y is a function of x and you cannot make y alone in this equality, it means you have to implicitly differentiate this equality with respect to x. This is the most important thing that you should not forget. Okay? So we will differentiate term by term. Derivative of x cubed with respect to x is equal to 3x squared. So done. Derivative of second expression with respect to x. As you see, you have multiplication of two functions. The first function is x. The second function is arctangent y. Derivative of first function is 1. 1 times the second function itself, tangent inverse y, plus the first one, which is x, times derivative of arctangent y. Derivative of arctangent y is equal to y prime over 1 plus y square. Okay? Equals derivative of right hand side. Derivative of exponential function is the function itself times derivative of power. Derivative of y. Of course, is not 1. Derivative of y is equal to y prime, since y is a function of x. So times y prime. The second step is to combine all expressions in the parentheses of y prime and then make y prime alone. I mean that we have x over 1 plus y square from here as the coefficient of y prime, and we have minus exponential of y in the parentheses of y prime, and I substitute the equality tangent inverse y. In the next step I will make y prime alone. Y prime is equal to minus 3x squared minus inverse tangent y divided by this expression x over 1 plus y squared minus e to the power y. Okay, so it's all. So it's done. Let's solve one more example, one more question. Find derivative of h of x for h of x is equal to x squared times arc tangent 5x, for instance. As you see, this equality is not, this function is not an implicit function. Okay, this is explicit function. So derivative of h of x is equal to derivative of first component. You have the multiplication of two functions, x squared and arctangent 5x. Derivative of x squared is 2x. Derivative of first one times second function, arctangent 5x, plus the first function, which is x squared, times derivative of arctangent 5x. Derivative of arctangent 5x is derivative of inside, which is 5 over 1 plus, right? 1 plus square of inside, 25 x squared. So it is enough for the time being. I hope you understand derivative of inverse trigonometric functions.